So in this video, I'm just going to give you a brief overview of integration. Obviously, from our non-constant acceleration video notes, we know that integration is the opposite of differentiation. So if I was going to integrate my function ax to the n, I use my integration symbol, which is the elongated s, and my outcome would simply be ax to the n plus 1 over n plus 1. In other words, we add 1 to the power and divide by that new power. So applying that to just some generic equation, y equals 2x squared plus 3x plus 2, we get, integrating, we get 2x cubed over 3, add 1 to the power divided by new power, 3x squared over 2 plus 2x, and then we're going to add in this constant of integration, which I'll talk about in a second. So obviously the first two expressions, x squared and x, are straightforward, but why does 2 go to 2x? Well, if you notice in our original function, we go power x squared, power 1. Well, 2 technically is 2x to the 0, and if you recall, x to the 0 is just 1. So when we integrate 2, we effectively integrate x to the 0. That gives us x to the 1 divided by 1. Now, where does the constant of integration come from? Well, if we're integrating a function, it may be something that will have been previously differentiated. And when we differentiate a function, the constant disappears, the number disappears. So we have to assume that there was maybe a number associated with this. So when I write my general equation, I should also write plus c. So how do we apply this to a generic non-constant acceleration question? Well, just let's say I start with a velocity equation, and that's going to be 3t cubed plus 3t squared plus 2t plus 2. And I'm going to say that when x is 0, t is 0. I'm going to want to find a displacement equation. Well, to displacement, I know that to get displacement, that's the integral of my velocity expression. So integrating 3t cubed becomes 3t to the 4 over 4. 3t squared would become 3t cubed over 3. 2t would become 2t squared over 2. Plus 2t, and then plus the constant of integration. Now this can be simplified slightly, so we could say that that's 3/4 t to the 4, t cubed, t squared, plus 2t plus c. The issue now is that this is a general equation because we don't know what our constant is, but if you recall, we had some initial conditions. When x is 0, t is 0. So now I can substitute those in. That would become 0, that would become 0. So anything with a t in becomes 0, leaving me with c. So in this case, my constant of integration is actually 0. That doesn't happen all the time. Your initial conditions might say when x is 0, t was 1. So you just need to be very careful there not to assume that. So now my actual particular solution is 3/4 t to the 4 plus t cubed plus t squared plus 2t. And you can use that to